Sometimes we need to access data contained within the controller, but not accessible via hardware tags. This data is contained within instances of objects that contain a variety of attributes specific to the individual object. There are many controller objects that we can access from Logix. A full list of these objects, as well as their breakdown by attribute, can be found within the Logix 5000 controller's General Instructions Reference Manual. One example is the wall clock time object. There is a single instance of this object within each controller, and here we see the table explaining the various attributes. Of course, when we go to the Date/Time tab of the controller properties, we can both read from and write to the wall clock time objects using the Logix Designer application. For example, we can set the data to match the configuration and data within the programming workstation. So the date and time is now set to what is in the workstation. Furthermore, the time zone is set to the local time zone, and daylight savings time is on and adding 1 hour to the time. Although we have the ability to manipulate this object from within the Logix Designer application, it is important that, for example, an OEM provide the ability to adjust these settings from within an HMI because their customers may not have the Studio 5000 software. To do this, the data must be accessible via Logix. To read data from objects within Logix, we have an instruction called Get System Value, or GSV. To write to attributes of an object, we have the Set System Value, or SSV, instruction. Let's begin by reading the date/time attribute. Looking in the table, we see that we can both read from and write to this attribute. When getting a system value, we need a tag into which we can store the results of the GSV. So let's create a tag now. According to the table, we see that we need a 7-element array of double integers. Now, opening our Logix, we can add the GSV instruction. Although we are limited to how frequently we can write to the date/time attribute, there is no such limitation to how often we read the data. So in this simple example, we will leave the instruction unconditioned and have the value read every scan. When configuring the instruction, we begin by selecting the desired object class name. Notice that because there is only one instance of the wall clock object, the instance parameter disappears. Now we can choose the desired attribute. Finally, we specify the storage location for the results of our GSV. Notice that we need to specify the desired beginning element within the array. This array will only contain the data from each scan of this GSV, so we simply specify the 0 element. Let's download the rung and check operation. Looking within the tag table, we see that the array is indeed being updated as desired. Let's create another GSV so that we can compare this date/time attribute to the local date/time attribute. Of course, we want a separate array into which we can store the results of this new GSV. Downloading the rung and turning to the tag table, we see that our new GSV is functioning. Comparing the values within the two arrays, we see that the local data is subtracting 5 hours for the time zone, as well as adding back an hour for daylight savings time. So let's take a look at writing to objects using the SSV instruction. Specifically, Let's see how we can adjust the time zone from within Logic. Since we can only write to the wall clock object once every 15 seconds, let's condition our instruction with an XIC that we can use to manually trigger the SSV. As with the GSV instruction, we begin the configuration by choosing the desired object. Again, there is only a single instance. Now we choose the attribute. In the case of an SSV, we wrap up by specifying the tag from which we will get the data that we want to write to the attribute. In the case of the time zone attribute, the data must be in the form of a string. So, turning to the tag table, let's assume that this particular machine will be running somewhere within the +5 time zone. Toggling the XIC and returning to the tag table, we can see the results of our change. In this case, we are 6 hours ahead of Coordinated Universal Time because Daylight Savings Time is enabled. Let's see how we can disable that. Returning to our logic, we copy and paste the SSV rung and then modify it to write to the Daylight Savings Time attribute. Writing 0 to the attribute, we see that our local time is now only 5 hours ahead of Coordinated Universal Time. Of course, we can toggle the bit from here as well. So, writing a 1 into the source and toggling the bit, we see that Daylight Savings Time is once again enabled.